So, morning everyone. I'm Lorenzo. For those who don't know me, I mean, just a funny anecdote about this presentation. I mean, yesterday we were chatting about what I'm currently prototyping for FFA, and a colleague just said, I mean, Lorenzo is the T guy, the kernel T guy. It's fun because I thought, well, when I got over becoming the CPI kernel guy, now I'm also becoming the kernel T friend. But I mean, it's just a joke. I mean, just this presentation is a way for me to present what we are prototyping in FFA space and in KVM Virtual Machines. To start with, what it is, what's FFA? FFA, well, as this slide shows, it's a firmware framework for A-profile processors. It's a communication mechanism between software images for normal world and secure world to communicate. And I can roughly define two components: a partition, or also called an endpoint in FFA. It's a software model that implements more and more service, and it's an isolation boundary. And a partition manager that is responsible for creating or orchestrating those boundaries. Well, just to give an example, a partition can be secure OS, and a partition manager is the hypervisor in the normal world or in secure world that orchestrate and manage those partition or endpoints. What does FFA provide? It provides discovery. So basically, through FFA, you can discover what partitions are present, the properties, and the services. It provides a mechanism, a standard mechanism to exchange messages in a synchronous and asynchronous manner. And also, last but not least, memory management between partitions, in particular to share memory between normal world and secure world. Well, a picture is worth 1,000 words. I mean, that's a sketch of I would say, typical FFA a typical framework deployed on an ARM system with the multiple VMs and hypervisor managing those and guest OSs in normal world, and likewise a secure partition manager running in secure world and orchestrating multiple trusted OS and software images. At the bottom, I mean, EL3 firmware that is coordinating the word switch between normal and secure. Yes, that's the overall picture. I don't think there is any question on that. If there are, I mean, just feel free to interrupt me. A key component, I'm not delving into that because, I mean, it's not the scope of this presentation, but a key component of FFA is memory management. In particular, I mean, the framework is there to standardize interfaces to share memory between normal world and secure world, and it's the components, the partitions, or we can call them endpoints, they rely on the partition messages and framework messages to share memory region between those software images. I mean, I'm not going into details because that's not really the point. I mean, the documentation is available, but well, at the moment, well, it's deployed in current systems to share memory between normal world and secure world for well, many reasons, where normal world and secure world needs to collaborate, and this is done over a standard protocol to share, lend, and borrow memory, all built on top of the SMC standard and the FFA protocol. So that's for memory management. It's not the scope of this presentation, but it's just there to show you it's there. Another key component of FFA is messaging. There are two flavors: direct messages and indirect messages, also known as asynchronous messages. Synchronous messages or message passing is a methodology specified by framework to send, where a sender basically hands over control to a receiver, and the transmission is, well, basically the message execution is executed, the sender blocks, and he waits for till he receives a response from the receiver. I mean, nothing new. I mean, that's a direct message, and direct message, and asynchronous message is, well, it's asynchronous messaging is not a new concept, but the difference is that a sender, basically through standard buffering scheme defined by the protocol, copies a message into a buffer, and instead of waiting, basically he returns to its context of execution. And through framework notifications, I mean, the sender is notified whenever the receiver completed message handling. That's what, well, in a nutshell, FFA messages are, and how they're defined the specifications. Notifications, I mean, I'll talk through the notifications because mostly that's what I've been prototyping for PKVM and KVM in general. Notifications are, well, what are FFA notifications? They're doorbells. They're a way for normal world or secure world to notify a counterpart in either, well, in normal world itself or secure world that something happened. It's basically a way a receiver notify a sender that something happened. And notifications are, well, there is work underway to enable those. Well, for hosts, they're already, at least as far as Linux is concerned, they're handled in the Linux kernel between normal world and secure world notifications. But they're also going to be deployed to be used for secure world to normal world notifications for VMs, and they're also the basis for asynchronous messages. There are use cases for PKVM, but before delving into that, there is a disclaimer there that whether there are patches out there for PKVM to enable guest VMs to trust zone communication, but we are at a prototyping stage. This doesn't mean that necessarily that this code will get into the PKVM code base. It's just prototyping code to test the concept, and then obviously the final decision relies on PKVM maintainers. So just that you know what this piece of work is all about. As I mentioned, FFA notifications are doorbells at their core. But to implement them, there are a couple of things that needs to be done. First of all, we need to find a way to enumerate VM, I mean, not as in hypervisor enumerating them, but as in the FFA framework and the Linux kernel host driver enumerating those VMs and make sure that he's aware of those partitions and so that he can handle, because VMs are created and destroyed at runtime. So I think there has to be any mechanism implemented in the kernel driver to handle those. It's not there at the moment, but there is a need for that. Doorbells for VMs, I mean, well, they're not really special, but the difference is that, well, for the host, notification is, well, a geek interrupt. For VMs, it's still a geek interrupt, but it's a virtual interrupt, so we need to find a way to inject an RQ into a VM. It's nothing new, but it has to be implemented. And another, say, fun thing to do is mapping those partitions. I was saying at the beginning that FFA deals with partitions, and we need to find a way to map those partition IDs to IDs that KVM can handle to to identify a VM, and those are VM IDs. So I think there has to be a mechanism in place to map those partition IDs to VM IDs and for the hypervisor to do that. But last but not least, I mean, I think it's obviously to notify, for instance, for secure world to notify normal world, we need to find an IRQ to be, we need to choose an IRQ to carry out that notification. It could be an SGI, it could be a PPI, or well, an SPI, and I think that there is a choice to be made there, but well, good news is that the FFA specifications define what needs to be, well, the set of IRQs that can be, the pool of IRQs that we can choose from, and that's about it. It's just informational. And there is work, of course, ongoing to upstream FFA notifications for host notifications that are in the kernel already, and there is work, I mean, to prototype and eventually upstream code to enable notifications from secure world to VMs for specific use cases that are being developed. And it's a collaboration between Linaro and ARM and Google. So, I mean, with the disclaimer I mentioned previously, when I say KVM, mostly the use case here is PKVM. It's not necessarily KVM, but well, there is no reason why this cannot be extended to KVM as well. To implement FFA, the first thing that we need to implement, so to allow communication between a guest and secure world, which is not there at the moment. There are, well, the patches I used to test this and prototype are out in the public, but it's still prototype work. So there has to be work in the hypervisor that actually allows a guest to talk to secure world. We need to, as I mentioned, allocate partition IDs to VMs and memory management as well. I mean, obviously, it works today for a host to secure world communication, but it has to be enabled also for memory sharing between protected VMs or plain VMs on top of KVM to secure world. There are a couple of interesting things to be done there. In particular, FFA, there is an ABI that allows us to share memory, but I think obviously the hypervisor needs to carry out all the IPA to PA management to make sure, because obviously, well, secure world deals with the physical addresses, so there is code already prototyped, again, not upstream in PKVM to do that memory handling and IPA to PA repainting, so it's called. Another interesting thing that is going on the mailing list at the moment is the FFA versioning coordination. I mean, it's kind of, I wouldn't say obscure feature in FFA, but it's still something that needs to be handled. It's there has to be a negotiation between, again, FFA specification changes some structures and calls between 1.0 and 1.1 versioning, and this versioning needs to be handled, and the coordination needs to be handled between normal world and secure world to make sure that when normal world talks to secure world, well, they talk the same language, so the same version, and there is this being solved at the moment on the mailing list. And finally, that's something that it's up for debate. I mean, it's how those notifications are injected into the guest, and that's, I've been talking to people this week as well, but I think it's technical detail that needs to be solved. I'm prototyping this work, I mean, as follows. I mean, the test case is protected VM talking to Opti. Opti is, well, I mean, by the way, I want to thank the Opti team at Linaro, because Opti, it turned out to be quite useful for testing this FFA, in particular notifications, and is very, it's good because it's open source and it can be changed, and that's what I needed to test notifications. And Opti provides today, it's all upstream, Opti code and the Opti counterpart in the Linux kernel handling this. Something that relies on FFA notifications to handle its bottom-half, top-half mechanism, which is basically a way to handle a security interrupt. Whenever Opti gets a security interrupt through the top-half, bottom-half mechanism, the interrupt is, well, the top-half is managed within the secure word, and then, well, Opti triggers a non-secure interrupt to notify the Opti driver counterpart in the Linux kernel to handle the bottom half, and when it's done, well, the secure word interrupt management is technically completed. How does it work? Well, I mean, as I mentioned, the top half is executing secure word that then raises an IRQ into the normal word, and that's what an FFA notification, well, that's mapped to an FFA notification that for a host is a real hardware geek interrupt. For a VM, it's a virtual interrupt that has to be injected into a VM, and that's what the prototype I put together is all about. That's for Opti top half, bottom half mechanism. I hope you can still read this slide. Sorry, it's very, the font is small, but yeah, anyway, I mean, that's how the FFA notification flow works for a VM. A notification in FFA has to be bound to through the hypervisor. So a VM requests a notification to bind notification 5 to SP0. Well, I mean, the flow, I mean, I think it could be boring to follow, but I mean, just to explain to you, a notification has to be bound because it can be before it can be signaled by a receiver to a sender, and then whenever Opti, for instance, has to notify a VM that something is going on, through FFA notification set, it raises what is called scheduled receiver interrupt. That's an interesting point because, I mean, probably the most important concept in this part of the presentation, because a scheduled receiver interrupt is raised in the partition manager, that if we are running PKVM, and KVM is the host where the interrupt is taken, and the host just issue an SMC to get from the SPMC what notifications are pending and for what partition IDs. Well, the SPMC reports that a notification was pending for VM 0 in this case, and that's point in time from the host we need to inject an IRQ into a guest to say, hey, there is a pending notification for you, and so that the guest can just retrieve through an SMC what notification it is, and finally receive the notification pending from the SPMC that something has to be worked on. That's, well, a minute whirlwind tour of how the notification work for a VM and how it has to be implemented. Now, well, the implementation, which is the summary of this presentation, is what I implemented, and that's what's up for debate. So, I mean, if you have questions or suggestions, just please do let me know, because this is what I've been running this presentation for. Again, I'm running a demo tomorrow. I mean, don't bring your 3D glasses, because this is just terminals and interrupts. So, I mean, there is nothing super fancy, but it just proves that the current scheme works. It's built on top of Google patches, as I said. They're public but not upstream. The prototype is built on top of those to enable guests to normal work communication in the first place, and it also solves, well, there are, as I mentioned, there are patches on the mail list to solve some issues, I mean, things that need to be implemented for FFA to be handled properly. The demo is about, well, as I mentioned, running the top half mechanism in a VM. Well, what it is in upstream is the host, but the same setup can be run within a VM. And there is work ongoing on that's what I implemented, is the notification pending mechanism. Whenever the host receives a scheduled receiver interrupt, it understands that there is a pending notification for a VM. That RQ needs to be injected into a VM, and there are multiple ways of doing it. One is what I implemented in the kernel, which is kind of, is not necessarily the easiest or simplest way, because I mean it could be racy, it's tricky code, to be honest. There is another way that is probably the way forward, but that's what up for debate, is go through user space, meaning that, well, whenever the host receives a pending notification, he can just relay the notification to a VMM that will end up injecting the RQ into the VM through the standard ioctl mechanism. It's a design choice, but it's there and it needs to be solved. The last bit, I mean, last bit is still important. There is something missing at the moment, and that's something that I'm thankful to opt it for, because, I mean, we managed to understand it's there. I mean, there is at the moment, it's a problem also for the host code. I mean, in FFA, there is a mechanism to retrieve memory. Well, whenever you share memory between normal world and secure world, there is a mechanism for the hypervisor to retrieve the region that were shared within normal world and secure world, to undo the mappings that were carried out whenever that memory was shared. So when we reclaim it, there is this FFA memory retrieve request that has to be implemented in the secure world to retrieve what memory regions were requested to reclaim them. But that's probable. I mean, probable, sorry. It means that it's not necessarily implemented in the secure world, but the hypervisor relies on it. So I think we need to implement a way for the hypervisor to probe this mechanism before actually sharing memory with secure world. Otherwise, what I'm saying is that there is no way to reclaim that memory any longer, because that API to retrieve the memory regions is not implemented. So I think this gives you, well, a very quick overview of what this prototype is all about. I'll be running, again, as I mentioned, a demo tomorrow if you have any questions, and if you have them today on what I did. If you have suggestions on how to improve it or how to change the design, just please let me know, because that's why I decided to give this presentation. And with that, I mean, I think this wrap up the presentation itself. And if you do have questions, please fire them off. Thank you very much for listening.
What's the meaning of the memory sharing between the secure world and the normal world? Can I see the content?
What do you mean?
The memory sharing. The memory sharing between secure world and the normal world, can the content, because the content in the memory can both be seen from the secure world and the normal world?
Yes, that's the purpose, for whatever reason. I mean,
no security issue. I mean, no need to encrypt.
For some reasons, well, it's
both ends have agreed to share that memory.
Yeah. So if it's a security issue, I mean...
So if there's a security concern, they shouldn't agree to share that memory in the first place.
The same virtual address or different virtual address per table?
I think it depends on what... I think I need to dig into the details, but I mean, yeah, we can go through it.
I think the interface does not mandate both sides use the same virtual address.
Yeah.
Ciao Lorenzo. Have you experimented with any other trusted OSs apart from Opt, or is it primarily Opt your main target for the demo?
Opti was handy because, well, I mean, thanks to Jens and Opti guys, I mean, they implemented the notifications in the first place, which is, well, good news because that's what I've been testing, but also Trusty is a target as well. I tested it initially, well, the FFA notifications, I haven't tested on Trusty, but it's on the cards.
Okay, thanks.
And as I said, the PKVM changes are subject to, well, it's a prototype. It doesn't necessarily mean that what it will end up upstream, because obviously it's a PKVM maintenance decision.
So on this point, how much of your changes in the series are actually PKVM specific as opposed to KVM?
I think I can answer by saying that there isn't much PKVM specific. The question is, there is a use case, well, yes, there is a case for PKVM. Is there a use case for KVM? Because otherwise, I mean, I think this should be KVM. There is nothing necessarily PKVM specific in there.
Yeah, exactly. And I think from a kind of pragmatic point of view, if you want to upstream this work, and if you look at PKVM in upstream Linux today, compared to PKVM in the Android common kernel, the diff is, let's say, not small. So upstreaming it as a KVM feature would probably be easier than as a PKVM only feature. Although it has to work with PKVM, of course.
It's definitely a fair point, and that's something we thought about. I don't think it should be PKVM specific. It isn't. So technically speaking, it's specific for the PKVM code part today because that's what I've been testing. That's the
Makes
answer.
sense. Yeah. Agreed. Okay, I have another question, which is a bit more technical, but regarding those partition IDs, how are they, so forgetting about mapping them to vmids, how are they actually registered? How does that work? Because, well, they're a key part of the notification, of course, because partition ID is the target.
They should be handled and registered by the hypervisor for the normal world VMs.
But what does that mean? Like if I boot a VM, who assigns the partition ID to that VM, and how does TrustZone know about it?
TrustZone doesn't necessarily need, well, TrustZone communicates it when you bind notification to it. It receives a VM ID, well, the partition ID, so let's not speak up VM IDs because it's confusing, but I mean, it receives it as part of the notification handshake at the beginning. But it's up, whenever you spawn a VM, it's up to the hypervisor to keep track of that partition ID, VM ID mapping. But TrustZone gets to know that VM ID when the notification flow is triggered.
I see. And
you say, I mean, bind this notification to, well, I'm VM ID, I don't know, X, bind this notification to SP0, which gets that notification ID in the process.
Right, because partition IDs, unlike VM IDs in a sense, have a special meaning. They are UIDs, right? So if I want to talk to a particular trusted app, for example, it will have a hard-coded, well-defined standard UID, won't it?
That's, I think the UID versus VM IDs, I mean, notifications are bound to partition IDs, not UIDs. You see I think it's confusing, but does it answer your question, or it's...
no, but we can take this offline.
Yeah, the UID versus partition this mapping, I think it's interesting. But yeah, I think let's take it offline.
Okay, thank you.
I think in the interest of time, I think.
We have 3 minutes of breaks.
So, yeah. I mean, grab him later if you have any other questions. Otherwise, I will give some time to have a break and start a presentation. Thank you.